Figures from last month. 47 Android, 43 iOS. Okay? So let's have a look at the trends. You can see that Apple, guys, you can see that Apple had a very good start. Okay? The iPhone was definitely a revolution, the first smartphone, and they started with 60% of the market. Okay? Google, with Android, decided to fight back, and the trend has been that Android has been increasing, and during the summer, Android has overtaken iOS. Okay? Windows is almost non-existent. Yeah? I mean, it's very important, you know, because when I ask you what is the main operating system, it really depends on which device you are going to use. You know, if you want to be an app developer, forget about Windows.
Linux.
Yeah. No, you need to choose between iOS, which is a form of Linux, or Android. Okay, but according to the trend, it looks that Android is going to continue growing. Okay, so which language will be the most, or operating system will be more popular in 3 years' time? Possibly Android, or maybe something new is going to appear.
Do they use C++?
Mostly programmed in Java, as far as I know.
Yeah, Java is the most common.
Is that for the UK or is it worldwide?
Worldwide.
Okay.
Okay, so now if you have a web server, Linux. Okay, so again, it's a very interesting market. So you have two main systems. One is Apache, and the other one is the Microsoft one. Okay, you can see that Apache has been dominating for 20 years, and now Microsoft is getting level. Okay. So Apache usually works with Linux. Yeah. Then we have Microsoft, and the third system is also an open source system with a Linux flavor. Okay? So you can see that in the case of web server, there's a mixture. There's no clear domination. If you remember well, when I asked you to get a host, I asked you to get Apache. Okay? I want you to have a bit of Linux experience as well. Okay? At the university, most of the machines are going to be Windows, but I want you to be able to do a bit of Linux as well. Okay? Because you don't know what your career is going to bring you to. Okay? What about supercomputers? Yes.
IBM. Kill you, Charlie.
IBM is not an operating system. Okay, so if you look at the trends for the last 20 years, so initially it was Unix, and then it has switched to Linux, so it's just the son of Unix, really. And Apple has tried and has failed. Windows is trying, but is almost non-existent. Okay? So if you want to work on supercomputer, if you are interested in using the latest computer that the British government is going to use for weather forecast, you need to learn Linux. Okay? So you can see that you cannot get out of uni and apply for a job knowing only one operating system. You need to have some understanding of others. Okay? Because depending on your environment and the job you will get, you will need one or another. It's quite a complex view. You don't have one system for everything.
IBM.
So now I have another question. What is the most popular operating system on Mars? Okay. So you can imagine that on Mars there are some constraints. Okay. That if your computer crashes, it's a bit difficult to reset it. Okay. So maybe we'll not use Windows. Is Linux much better?
Yes, of course it is.
Yes.
You wouldn't use Linux on Mars. It's not reliable enough.
Unix.
Resource.
So you need some specialized operating system. So you have the one which is on board of Curiosity is called Integrity. Okay. So you can see that the computer which is on board is not a fantastic machine. Okay. Not as good as what you have in your laptop. But you can imagine that there are very different constraints. Okay. That it needs to be working in real time. Okay. Which means that if something occurs, the rover has to react. Okay. Cannot just wait for some time. It needs to react in a split of a second. Okay. You cannot reset the button. There are also some issues with communication. Okay, it means that when it's on Mars, if where the rover is facing the Earth, communication is possible. If it's on the other side of Mars, you cannot communicate. Okay, so you can see that a lot of the functions can be time critical. So it had a 2-year mission. And the aim was to find evidence of life, and the outcome has been they haven't found life now, but they think that in the past they may have been. Okay, and the system is still running. Okay, it was supposed to go for 2 years. We are already in the 3rd year, so the computer hasn't crashed. So it's a good operating system. So that's a sunset on Mars. Okay, so what is this operating system trying to do? So make the execution of your programs easy. Okay, it needs to be transparent. When you are using a computer, you don't want to worry if it's a Linux, if it's a Windows. You just want to double click on the icon of your application and use it. Okay. Also, you want the operating system to use the hardware in an efficient manner. Okay. It's not just about hiding everything, it's taking advantage of your hardware. Okay. If you have an 8-core processor, it would be very good if your operating system could say, okay, you have 8 cores, let's use the 8 cores and not let's use only 1. And if you use the wrong operating system with the wrong settings, you will just use 1. And you will have 7 cores doing nothing. Okay. Also, an operating system allows you to share resources. Okay. So you will have an operating system on the server, and several clients will be able to interact with that server at the same time. Okay. And that's the operating system which allows you to do that. Obviously, you want to have your application which can move from one system to another, and the operating system is trying to make you hardware independent. Obviously, you want security. Okay, you don't want to run one application and start deleting everything which is on your computer. So the operating system is trying to keep everything well protected. And obviously you want a system which is reliable. Okay. So on a PC it doesn't matter that much if it does crash, but on Mars it's a really big problem. So we have already looked at the architecture of a PC, and the architecture is pretty much the same in your smartphone. And basically you have all these different components you have your processing component, you have some disk controller, you are controlling your devices, and you need to share and organize all that, okay? And the operating system is dealing with that. So an operating system is allocating resources to your programs, is controlling your programs, and also the operating system is a program in itself. Okay, it's always running on your computer. Okay. So imagine that you have a PC with only one CPU, but you want to run several applications. Okay. You want to write your report. At the same time, you want to listen to some music and check if some new emails are arriving. Okay, so you like all that stuff running on your PC. However, if you have only one processor, in principle, you have one processor, one application. The solution is to use something which is called multitasking. Okay, something that women are very good at, is doing several things at the same time. Okay, so you have a resource and you are going to share it between your different applications. Okay, and that's what the microprocessor, the operating system is going to try to do. Make sure that all your applications are running at the same time in a very seamless manner, so that when you are typing your report, your music doesn't stop. Okay, and that your emails are still coming. So the operating system is trying to organize, making sure that everything seems to be happening at the same time. But you need to remember you have only one CPU, you have only one calculator, so you have one operation at a time. The three things are passing one after the other. So you need to share the time on your processing unit. Okay? So either you have one person using several applications, so all these applications are competing for your processing unit, or you have one processing unit and several users. Okay, so when you are logging in on a server, several people are trying to access the data on this server, and you don't want to be waiting for other people to have finished. You would like everybody to access the data at the same time. So in order to solve this problem, what you need is called a scheduler, okay, in order to manage the resources. So what you want is for this scheduler to be fair. Okay? If you have 10 people trying to access a server, you want everybody to be waiting more or less the same amount of time. Okay? It wouldn't be fair that one person gets a high priority and everybody else is waiting. Also, you want to be clever. You want the system to be able to discriminate between the type of applications. Okay, so for example, in my example, you have one application which is listening to some music, and the other one is checking that new emails are coming. You don't need to check your emails every second. Okay? For us, if we have an alert every minute, it's maybe a very reasonable time. However, you want your music to appear to be continuous. It would be right to wait for 1 minute for getting the next note. Okay? So depending on the application, you are going to treat them slightly differently. And obviously you need to be efficient, try to optimize all those parameters. Okay, so let's look at an example. Here I have 5 applications that I would like to run at the same time. So when I start my computer, I want to run this application. And after a while, I would like to start another one. So here I'm showing you when in time I'm starting the new application. And how long this application is going to last. Okay? So one strategy is to say, the first application which is there, I just run it until it does finish, then I run the second one, then the third one, and so on. So typically that's called a first in, first out scheme. And you run the application one after the other. Okay? So we can notice that, for example, the last application, which was very quick, okay? For running that last application, I need to wait for all the application to finish, okay? Which, in principle, is not what you wanted. You know, you wanted to check something very quickly and then go back to your other applications. So this system is not very good because if you have a short application, you will only you risk to run it only at the end after all the long applications have finished. Okay, so you can see that the yellow application would finish at time 20, whereas it arrived at time 8 and could last only 2 steps. Okay, so it feels that such a system, when you run each application one after the other, is not quite a good system. So another type of scheduling is called the round robin. Okay? So you are going to run an application, and when there is another application starting, then you are going to divide the time, and you are going to split your applications in small chunks. Okay? So you start running application 2, let's say for 1 time step, and you go back to 1. So you are going to alternate between 1 and 2. And then application 3 starts. So you are going to alternate between 1, 2, 3. And then 4, and so on. Okay? Which means that in this case, for example, our short application will be finished at time step 15, while in the previous one it was finishing at time step 20. Okay? So you can imagine that for a long application which takes 2 hours, finishing, imagine we have 2 applications, one of 2 hours, one of 5 seconds. In the first case, you will wait for 2 hours for running your 5 seconds. In the second case, after a very short amount of time, you are going to run your short application. So the long application will last 2 hours and 5 seconds, and your short application will maybe wait 10 seconds, which is a better policy. Another scheme, which is, let's do first what is short. Okay? So you get your application running, and you are going to run the short one, number 5, before number 3 and number 4. Okay? Because the 3 were waiting, and we give the priority to the short one. So it's another strategy. The problem of this strategy is you need to know how long your application is going to last. Okay? In the previous one, every application is chunked in pieces. So if you don't know the time of your application, it doesn't matter. Okay? In this one, where you choose the longest, the shortest first, you need to know what is the shortest. Okay? So if you are running jobs, in this case, imagine you want to run a supercomputer. I mean, the university has a supercomputer, and you say, yeah, I want to run this job. It's going to ask you, how long is it going to last? Say, okay, it's a job for 10 minutes. Oh, it's a short job, so we give you the processing power. After 10 minutes, they shut you down. If you needed 11 minutes, tough. Okay? So you need to know exactly the time you need for your application. Okay? Which is possible in certain circumstances. Also, in that case, a person who has a long job may never get their job running. Okay? Every day there's someone who is going to come with a short job, and the person who needed 1 full day of processing will never get it. Okay? So you can see that there are many strategies, and you need to find a good compromise, and this compromise depends also on the type of applications you are running. Okay? So if we look at Windows XP, okay, so typically Windows has been made for personal computers. Okay? So you have usually one user running many applications. So the objective for a Windows operating system is to have the feeling that you are running in real time. You double click on something and it's running. You don't have to wait. Okay? And also it's about having the impression that everything is working well. Okay? So it's about the perception of the user. And we know that we are only humans. Okay? So maybe an unfair strategy is going to be run, but if we feel that everything is working the way we want it, it's fine. Okay? We just to have the impression that performance is good. So that's what is behind a Windows XP operating system. So in practice, they will use a round robin, and you will have different types of applications with different type of priorities. Okay, you will have high priority tasks, and they will be round robin around those, and they will have lower priority tasks, and there will be a round robin there as well. So real-time processes will have the highest priority. When you touch your keyboard, you will get the priority. You touch the key, it's going to analyze the data. Okay. And once you have starting using an application, you are going to start chunking bits. The priority of that application is going to be lowered down, because it's okay, it may be a certain priority, but it's getting a bit long, this application. So let's lower its priority so that other applications have the opportunity to be run as well. Okay, so it's a compromise between the round robin and the other one, which is shortest application first. And each time you touch your keyboard in one of your applications, priority is going up. Okay? The user is interested in that application. We want the user to perceive good performance. So if the user is touching the keyboard, priority is going up. Okay? So that's a good trick. When you are running several things on Windows and you want one application to go a bit faster, double click in that window. Okay? Because Windows will understand they are interested in that. Let's give them a bit more resources. Okay? So if we go on my machine and we look at the task manager, you are all familiar with the task manager? Yeah? So you can look at the processes which are currently running. So we can see that there are some stuff like win-logon. Okay, so that's part of the kernel. Okay, I logged on my machine. I didn't run that application. It's automatic. It's always running on my machine. Yeah. So if I look, I click the right button. I don't know if you have done that. And you look at the priority. You can see that this process has a high priority. Okay. Automatically, Windows said, okay, logging with Windows is something very important. I need to listen if people want to log out and so on. So that must be at a high priority. On the other hand, I'm running Chrome, and the priority is just normal. Okay, it's not critical. So Windows gives me a normal priority for running my browser. Okay, and for my PowerPoint, it's running. Where is my PowerPoint? Normal priority as well. Okay? So basically, all the applications which has to do with the operating system have high priority, and the one I'm running have average priority. But the thing is, I can change the priority if I want. Okay? If I'm running, let's say I have a big job, let's imagine you are doing some image processing with Photoshop. You know, some applications takes forever. Yeah. So if you try to do some complex image processing, you have a big image, you click, and you wait for 10 minutes. Yeah. So what you can do is, before clicking, give your Photoshop a low priority. So it's not going to freeze the whole machine. It's going to work at a slow pace. Okay? So instead of 10 minutes, maybe we'll need 20 minutes. But during that time, your machine will be alive and you will be able to surf the net, check your emails, and write a report. Okay? So an advanced user of Windows is playing with priorities. Okay? Obviously, you need to play it well, because you can, in the worst case scenario, you crash. Okay? It's not a big deal. But if you lower too much the priority of the operating system, your system is not going to be responsive and you may crash. Okay? But I would recommend experimenting a little bit. Okay? Try to see what it's changed to higher a priority of one application and lower another one. Okay? Okay, so now we mentioned Linux. Okay, so we have seen that Linux is not used so much on people with PCs. It's used a lot on massive computers and on servers. Okay, and so it means that there are machines that usually are shared between people. Okay,
More functional.
It's a different type of machine, you know. You have a supercomputer and several people want to use it. So it's not a desktop computer where you are the only user with many applications. Now you have several applications, but you have many users as well. Okay? Which means that the objective is still to be responsive, to try to be real time, but now you want to be fair. Okay? It's not anymore about the user experience, make people happy. It's about being fair. If 10 students trying to access the same supercomputer, each student should get the same amount of time. Otherwise, it's not fair. Okay? So you can see that the emphasis is different from a Windows. Okay? And depending on what you are doing with your computer, one system may be better than another. So again, they are using round robin for the processes which have of high priority, and then they are using FIFO, so first in, first out, for the other processes. Okay. Obviously, they are using also a system of credits, which means that the more time your processing lasts, the lower priority is going to get. Okay? So it's a different way of finding a compromise between large, short processes which should be going first and trying to be fair. Okay? So another thing which is very important about operating system is security. Okay?
That's why you use Linux.
And Linux is well known for being more secure than Windows. Okay. So you want to make sure that if you have several applications running on your system, that they are running independently. They are not starting taking the memory of another one and so on. Or if someone is trying to connect to your computer, they are not going to be able to extract data and run applications. Okay? So security is very important, but again, it has a price. Okay? The more secure system, the slower the system is going to be. Okay? So if you are going to run, if you are using your computer just for doing video games, is it that important that it's secure? Okay? Obviously, if you are running on big military projects, security is really essential. Another thing is that operating system needs to be dealing obviously with networks, and also the operating system, you have to understand, it's are huge pieces of code. Okay, we are speaking tens, if not hundreds of millions of lines. Okay, in this operating system. So Windows here is around 80 million. Some very basic Linux systems are around 16 million, and some other Linux systems are in the hundreds. So they are huge pieces of software. Okay, so that's why there are always bugs. That's why you always get patches. Okay, never Linux, never. So it's so big, it's so difficult to maintain them. They've been written for decades. Okay, so they are very complex systems. And obviously, just running your operating system will take a lot of your RAM. Okay. Okay, so after this introduction about operating systems, I would like you to do a bit of experiments. So basically, I want you to go to the dark side. Okay? Because so far, most of you have just used a system based on Windows. Okay? Linux systems are based on Windows as well. Okay? Everything is nice and shiny. You just double click and scroll things. Everything looks nice. But what is behind that? Okay? If you look at some science fiction films, you see this black screen with these lines either in white or in green. Okay? And that's what we want to explore. Okay? So we want to go to the dark side. Okay? We want to look at something like that. Okay? Who has already been there?
Yeah.
Yeah.
For networking.
Yeah. And you have survived?
Yeah.
Well done. So that's where I want you to go for this activity. Okay? So I want you to test two operating systems. One is Windows. So either you have a Windows machine or you go to the library and you will get a Windows machine. And Linux. So either you have a Linux machine or you have a domain which is using a Linux server. And since I asked you all to get a domain with a Linux server, you all have access to a Linux machine. Okay? So that's the two that I want you to explore. So if for people who are a bit scared, let's get started with the Windows machine.
So a quick question, can you get a virtual machine on your machine?
A virtual machine on
your Windows machine?
Yeah, why not?
Yeah, they'll do the same job.
Yeah. So if I want to go to the dark side,
Which kind of Linux do you want us to use?
whatever. So if I want to go to the black side on my Windows machine, what should I do? So I'm writing the command cmd, and here I am. Okay. So I can go, for example, on my Edge drive, and at the content of my Edge drive, I can go to my files. I can go into my teaching directory, and I can go to IT Toolbox. And I can see the content of my IT Toolbox directory. Alternatively, if I want to use the user interface, I just go to desktop, teaching, IT Toolbox, and you can see that the information is identical. Okay. However, the advantage of being here is that I have full control. I can do many more things that I couldn't do here. Okay? Let's say that I want to get in a file the list of all the directories which are here. How do you do that? While here, it's very easy. Okay? In one command, I can copy all the content of my directory in a file. If you use the Windows interface, it's not possible. Okay? So using the interface is nice, it makes your life easier, but also it gives you a lot of limitations. Okay? So that's why people who are IT professionals, for certain tasks, they move to the dark side. Okay? It allows them to do many other things. I mean, if you look at people involved in networking, they are there all the time. Okay? Because it's much quicker and you can do many more things. Okay? So it's important for you to be aware of that world and to start using it and be comfortable with it. So now I have a question. How is the dark side on a Mac?
White one.
The dark side is white on Mac. Okay, what a surprise. And here is how to access it if you are using a Macintosh computer. Okay? So, if you have a Mac or have access to a Mac, feel free to explore that operating system as well. It's based on Linux, so it's not that different. Okay, thank you very much for your attention.